He says, I'm Graham Warwick. I'm the executive editor for technology at Aviation Week, and I'm based in Washington, D.C. I'm originally from Scotland, but I'm over here now. So if, like me, you have been following this summit all through yesterday and today, you'll be well aware that we have more than one elephant in the room. One of them, as Dominic said right at the opening of today's event, one of them is hydrogen production. But to me, an equally big and grey and wrinkly elephant crowding the room is the fact that we could retrofit all the regional aircraft in the world with zero-emission propulsion. We can even play a role in revitalizing regional aviation, and we will only decarbonize a small fraction of aviation. The big emitters in commercial aviation are the tens of thousands of medium and long-range single and twin-aisle aircraft that fly hundreds of millions of people globally every year. But interestingly, the narrow-body aircraft appear tantalizingly close, or tantalizingly within reach of at least some of the decarbonization propulsion strategies out there. But are they really within reach? Is it a flight of fantasy that we can think of as zero-emission single-aisle aeroplane? So to discuss this, I'm joined by an expert panel that represents the airline, the airport, and the propulsion disruptor that is bringing zero-emission powertrains to the market. So I'm joined by Lahiru Ranasinghe. He's head of net zero at EasyJet. Lahiru is responsible for the whole spectrum of EasyJet's decarbonization strategy, which is embedded in the airline's business transformation. He's an engineer by training, and he previously worked with Atkins and Airbus. We're also joined by James McMicking. James is Chief Strategy Officer for ZeroAvia, our hosts. James was previously in the automotive powertrain business, so he saw a similar transition in propulsion there. He went on to take part in setting up the Aerospace Technology Institute, ATI, which has played a key role in helping ZeroAvia bring its projects to reality. And he decided to move over to ZeroAvia and take over a strategy. And our third panelist is Matt Gorman. Matt is Chief Sustainability Officer at London Heathrow Airport. He also serves as chair of Sustainable Aviation, which is a unique coalition of UK airlines, airports, and manufacturers that provides advice on transitioning to net zero sustainable aviation to the government and to other entities. He represents Sustainable Aviation on the UK's Jet Zero Council, which is a very high-level organization set up to try to guide the UK towards net zero aviation. So I'm going to start with you, Lahiru. EasyJet, as far as I can tell, EasyJet only flies single-aisle airplanes. You don't have a regional fleet. You don't have a regional, a little flock of regional airlines sort of flying alongside you. So what do you see are your options as you look forward to decarbonize that size of aircraft?
Graham, you're absolutely right. I think we might be one of the most boring airlines for a plane spotter, because you basically have small, medium, and large of the same white and orange aircraft. But in terms of looking to the future, the way we see it is that we need to change the way we think about this from looking at fuel to the energy and the energy ecosystem. And fundamentally, the two things that we think we have to look at here is, what is the cleanest source of energy that is appropriate for a given application? And secondly, what is the most efficient source of energy for a given application? And in short, what we're saying there is it's really horses for courses. And what that means for us is that, well, for these industries, we believe that you electrify anything that you can, which will really be at the small end of the market. That hydrogen then really comes into its own for in fuel cell form for the regional market, as we've heard a lot about. And for us, up to the kind of aircraft that we operate, A320, 737, you're really looking at hydrogen combustion in a gas turbine engine. Of course, you go beyond that within the timeframes that we are talking about, up to around 2050. Larger aircraft, wide bodies, while technically possible, we see SAF as being the mainstay for that part of the market. Now, the reason why we see hydrogen as so important is, for those reasons that I just gave. But I have to stress that we also see it as very complementary with SAF for the long-term decarbonization of this industry. And the real reason for that we see is, in a world where we do have to rely on SAF for decarbonization, a massive proportion of that is going to have to come from power to liquid, which will of course require green hydrogen and carbon capture all with renewable energy, in a world where there are competing demands for that renewable energy. And all the studies that we have seen, all the work we've done with our partners, they indicate that the direct use of hydrogen in liquid form from an energy ecosystem perspective is significantly more efficient than using it as a component of a power to liquid SAF. But the additional element of this is, as operators like ourselves, as narrow body operators move towards hydrogen, it then eases some of the pressure on the SAF supply chains that allow more of the SAF to be freed up for the wide body and long haul markets. So in using hydrogen, it's actually not just decarbonizing the narrow body sector or the regional sector, it is helping to decarbonize the whole sector overall. And clearly there are massive challenges ahead in terms of going from the development side to an operationally and commercially viable product and service. But we're extremely encouraged by all the work and all the progress that's been happening and accelerating over the last couple of years. And we're starting to see lots of opportunities coming up as well.
Thank you, Lahiru. So James, what as a hydrogen fuel cell propulsion developer, how can you help EasyJet and other operators, and there are many, many of them, of these very important class of aircraft, particularly the single aisles, which are really the workhorses of aviation?
Yeah, absolutely. So, I mean, I agree with a lot of the things Lahiru said, with one exception. As a company developing new technology for zero-emission aircraft, our ambition is to put these engines eventually into every variant of future aircraft. And, starting with small aircraft, scaling that technology up, and we could maybe get into how we're going to do that a little bit more later in the panel session. But we believe fundamentally that is possible. And there's good reasons to do it as well, because fuel cells are very efficient engines. So in terms of using the energy on board the aircraft and multiplying the losses you experience back up through the value chain to generate that fuel, generate that hydrogen, the efficiency at the end use is really important, and fuel cells are more efficient than combustion. So that obviously saves you cost through the value chain. And it saves you weight and volume on board the aircraft in terms of fuel tanks as well. So there are good reasons to try and strive to scale these engines for this segment of the market. And then, of course, on the emission side, fuel cells offer the prospect of eliminating all emissions from flight. So not just CO2, nitrous oxides as well, and avoiding water vapor effects from high altitude flying as well. And these are the things that make it very attractive, all combined. And then maybe the final addition in terms of why hydrogen electric is attractive is around maintenance costs as well. So not only are we going to save on fuel consumption, which has an economic benefit for the operator, but also in terms of engine maintenance. So that's our mission, scale the technology. We think we can get there. We think we have to get there as an industry as well to achieve these the long-term future of sustainable flying with the workhorse of the industry, which of course is the narrow-body aircraft. And this is where we have to find the best solutions if we can, because they're going to continue to grow and be popular.
Thank you, James. So Matt, you represent the airport. So the airline buys the airplane, the airline operates the airplane, the airline buys the fuel. You're the airport. You have to enable that. That fuel has to be that, if that's their choice, you have to be able to enable that fuel to be there. So what is the role of an airport, or a viewpoint of an airport in this, when we talking about probably the airplanes that occupy your airport more than any other type of aircraft, the narrow body?
Yeah, no, really good question. And Actually, coincidentally, I'm joining you all from New York today, having flown on the first transatlantic 100% SAF flight yesterday. So I may, if you'll indulge me for a second, I'll just reflect briefly in my role as chair of sustainable aviation and just echo some of Lahiru's points on the complementarity of SAF and hydrogen, but I'll absolutely answer the airport point. And actually, the reason I'm wearing a slightly funkier shirt than I might normally for this kind of presentation is I feel it's kind of on brand for Virgin, really. So I'm in a kind of, slightly dressed down mood today. So I thought Lahiru summarized it brilliantly. We have to get to net zero by 2050. Both hydrogen and SAF will play a role, but they'll do different things over different timescales. We think 70% of all global aviation emissions roughly come from mid or longer haul journeys. We're certainly, from all the evidence and conversations I've had with OEMs, I can't see a hydrogen alternative by 2050, possibly after that. So I think SAF is vital for those mid and long haul journeys. But for the narrow bodies we're talking about here, I'm hugely excited by hydrogen. James knows I was at ZeroAvia's hangar at Kemble Airport in Gloucestershire earlier this summer in the UK. And looked under the aircraft and asked what the little washing up bowl was under the aircraft catching drips. And I was told, well, the exhaust drips water, and when it's parked in the hangar, we catch the water. And isn't that an amazing vision? The idea that we could fly and the only byproduct would be water. But we don't have those narrow body planes yet. So we need to scale a solution now. We all have to cut emissions now. So we introduce SAF now. We fly all of the narrow bodies before hydrogen comes in on SAF, and then there'll be a phase over to hydrogen. So what's the role of an airport in all of that? We don't want to be the blocker as Heathrow. We want to enable, but it's a really interesting one for us because exactly as you point out, we don't buy the planes. We're not directly in the value chain. So we're keeping what I would describe as an extremely active watching brief on the development of the technology. We had UK government funding, Research Council funding to look at the infrastructure requirements for Heathrow. And we concluded that given the likely rollout of the technology, we think lorry deliveries of hydrogen see us probably through to the late 30s, early 40s. But there'll come a point as the market develops where three things will need to happen. Firstly, we'll likely need a new pipeline to bring hydrogen as a gas to Heathrow. Secondly, we're going to have to liquefy it at the airport, which is very electricity hungry. And thirdly, we're going to need to move it around the airport, possibly with a new hydrant system. And all of those are significant investments, either by us or by some other part of the value chain. So our role at the moment, I would sum up as active watching brief and research, so we understand exactly what role we need to play and when as an airport. And just to put that electricity in context, for Heathrow, forget hydrogen planes, we probably need double the amount of electricity today just for things like cars and heating and plug-in air conditioning for planes by the mid-2030s. If we need to then liquefy hydrogen on site, we're potentially talking about another 4 times electricity again by 2050. So these are huge amounts of electricity that we're thinking about for Heathrow.
Wow. I'm not sure I need to explain what a lorry is to some of our audience. A truck.
A truck, sorry, yes. Divided by a common language and all that, sorry.
So I want to come back to you, Lahiru, to again kind of dig into what the challenge that EasyJet faces. So EasyJet operates 3 sizes of a single type of airplane for a very good reason. That is the most efficient, lowest cost way to move people around. You have the same maintenance system, the same training system, the same supply chain, everything like that. And by their nature, single aisles are very flexible airplanes. You know, we fly single aisles on, you know, a 200-mile flight. I don't know what from London to Paris is, but it's not very far. And then, you know, with the weekends, we fly them from, you know, Norway to Spain or something, or, you know, or Sweden to Italy or something. Same airplane, right? When you look at, it's key to me is this business transformation part of your role. Is EasyJet prepared to modify its business model to enable that transition where you have aircraft that may be limited in their role until the technology catches up? I mean, could we see an EasyJet that has sub-fleets? It's so different to how you operate today.
I mean, the simple answer to that is we don't like the complexity. but we also don't see a way around it, because we have these decarbonization targets that we have as an airline and as an industry. And with that, there are certain truths that are difficult, that are going to make our business and our life a bit more difficult, that we still have to get to grips to. What I would say there, though, is that yes, that it is a journey. We're not going to flip the fleet in over a couple of years. We use any of our aircraft right now for a little over 20 years, so it will take some time from the first aircraft entering the fleet to having a large-scale fleet and the majority of the fleet of those kind of aircraft, and we will have sub-fleets in that period. But a couple of things I'd say is, one, we have a massive base structure around Europe. Some of them, like Gatwick, are massive. Some of them in other parts of Europe are 5-6 aircraft. So we do have the capability to ring fence to ring fence the localized operations in a way that you have a sub-fleet that might be confined to a single airport or a single base for starters, and then grow from there. The second thing I'd say is that while you have more limited range on the designs and the concept for the aircraft that are there, 2,000 nautical miles is plenty for the bulk of our network, because our average sector length is a little over 1,250 kilometers, so well within the range of that 2,000 nautical miles. But one of the opportunities we see, plenty of challenges with hydrogen, of course, but one of the opportunities we see in the early days of the hydrogen transition is that we would have the capability to tanker on hydrogen and do a lot of our shorter sectors there and back with a single refueling only at the base. So it's not that we'd have to have hydrogen infrastructure or supplies situated all over Europe for us to be able to operate a network. We just need to have it at the base, which then drives that localized demand very fast as well. The one thing I would say is that while the other end is not a constraint in terms of operating, what we do have to figure out is the diversion factor. So in the event that you do have to divert an aircraft and refuel to get it out, what happens then? And that to us for the early days is a bigger question than having infrastructure everywhere. And as I said, it is quite a journey. So by the time we get into the later stages of this, and you have more infrastructure, more supply, cheaper hydrogen, then that we anticipate would give us the opportunity to fly further and further with refueling at the other end.
Matt, I'm going to come to you. So forgive me if I oversimplify here, but looked at from the outside, the one thing London Heathrow doesn't want is small airplanes. It doesn't want lots and lots of little airplanes taking up takeoff and landing slots that could be used by single aisles or long haul airplanes. As we go through this that must be a challenge when we look at going through this transition, because this transition starts with smaller aircraft. It'll get to maybe 80, 90 seats at some point before we make this jump. What's that mean for Heathrow? How do you begin when you're kind of like in this dichotomy of wanting to embrace the transition, wanting to enable the transition, but your customer base is already on that big end and kind of waiting for this to happen?
Well, I think I talked earlier about the kind of active watching brief that we're keeping. I mean, I think, let me break it down. We do have some smaller aircraft at Heathrow today. I think probably the smallest size we've got, some of our Logan Air flights that serve Scotland are probably 80 seaters at the smallest. We've had Flybe in the past serving that size. So if we get the early generation of hydrogen potentially up to that size, we would absolutely expect some of those movements to shift at Heathrow. Just as an aside, the UK government has a very strong focus on net zero, but moving towards zero emission domestic air travel. And you could expect to see policies to support that. So we need to be ready for that. I come back to my point on we think lorries/trucks will get us a long way there in the early days, particularly given that part of the market is relatively small for us. But I think given current market forces, we would expect narrow bodies will continue with increasing volumes of SAF until there's a commercially viable alternative, and will then begin to switch, and long haul would continue with SAF. I mean, I guess the only thing that might change that is if the relative cost of these different technologies, SAF versus hydrogen in particular, and the fuels that fuel them, if those relative costs shift significantly, you might see, you know, a faster shift, for example, to narrow body than we might currently be anticipating. But as I say, we've got a timeline at the moment of the rollout we're expecting. We do think there'll be a need for significant infrastructure investment to enable narrow body hydrogen, and we are building that into our long-term master plan for the airport. So space for liquefaction and storage, beginning to think about the hydrant system, beginning to have conversations around the national hydrogen distribution. But it feels like we're in the right place at the moment. It's a bit of a chicken and egg. We don't want to invest too early, or others to invest too early before we know exactly what's needed. We don't want to invest too late either. But we think we've got the right kind of long-term plan at the moment.
And just very quickly ask, you talked about electrical power. There are already a lot of airports around the world that are starting to put solar arrays into the available land that they have. Is that an option for Heathrow? Can you do that, or are you really going to have to reach out into the wider grid?
We can, and we're absolutely looking at that. Actually, we're just, I'm taking to our executive and board over the next few weeks our new energy strategy, which looks exactly at our long-term forecasts, how we become more efficient, local renewable power. But what that tells us is that absolutely there's an opportunity for solar, both on our site, on land near Heathrow, either owned by us or owned by someone else. There's also opportunities for micro wind generation, even wind turbines a little bit further from the airport. But we don't think, from all the work we've done, that renewable generation gets you above, probably maxes out at about a quarter of our peak demand as an airport at the moment. So it's absolutely something we'll need to drive, but that connection into the national grid and an additional connection, at least in the future, to bring green electricity in is going to be key to us. We'll be looking at how we invest in what are called power purchase agreements to invest in offsite renewables further afield. And worth remembering, there are also lots of reservoirs around Heathrow, which are a further opportunity potentially as well. But I still don't think that takes you much above the 25% I mentioned.
So James, when we were doing the prep for this, I was trying to explain that, you know, when the jet engine came in, there were a bunch of scientists sat around and said, here's the first jet engine, it's really not that great, but here's the theoretical potential of the turbine, the gas turbine. And we are now producing, I mean, big long-haul turbofan engines are extraordinarily efficient. We're eking out a few percent efficiency, asymptoting to the absolute theoretical limit. And you know, we've got incredibly efficient engines. When you look at a fuel cell power, what is the art of the possible? If you look at that roadmap, is, you know, power to weight, thermal management, air supply, all of those things, is it within the realm of the possible to build a system big enough to power a 150 or a 180 seat, 2,000 mile, 2,000 whatever aeroplane?
Yeah, well, it's definitely within the realms of possible. You know, clearly we don't have all these technologies today, but we understand some of the things we need to do to get there. And you know, it's not unreasonable to conceive an engine that would be in excess of 60% efficient at converting power to thrust, which is well beyond where we can expect gas turbines to get to. And already today, with our megawatt, sub-megawatts, just over megawatt engine technology, we're more than twice as efficient as the gas turbines we're replacing in those products. Now, clearly, they're not as sophisticated as the really expensive engines on wide-body aircraft, but it's a huge leap with the very first iteration of the technology. And you look back, you know, since you referenced the jet age, you know, the amount of progress that's been made with 60, 70 years of R&D and hundreds of billions of dollars, and you apply that thinking to where we might be able to take hydrogen electric power, and, you know, one can only imagine the art of the possible, right? And we're talking about engines that will absolutely be able to pack a lot more power for a given mass, comparable to the sort of engines we have today. very high efficiency. Obviously, you have to look at these things at a whole system level. Because of the extra efficiency, you have less weight on board for fuel. So you can trade these things off differently. So we have to think differently as well about these future aircraft. And it's also worth remembering, in the jet age, of course, the early turbines were rejected and indeed quite difficult to sell at the time for the innovators, right? The early innovators, you think of Whittle, and eventually the businesses and governments caught up with the idea and actually made it happen. And a lot of the early objections are around material feasibility and these engines going to melt and all the problems are going to be encountered. And we hear some of the sort of parallels to that, I suppose, with this technology, but for sure we can imagine how we can overcome those things and continue to scale the engines. And it is about material development. It's about pushing pressures, temperatures, lightweighting these things. But we're starting with, from an aviation point of view, relatively simple systems, automotive technology that's being designed to be aerospace worthy, but fundamentally there's a long way to go in terms of the improvements that can be made.
Thank you. So Lahiru, you're a customer of the industry. You're a customer that's moved very early to embrace the, to engage with industry and embrace this idea of decarbonizing propulsion. We just literally had the news that Rolls is, go through, we British say yet another reorganization at Rolls-Royce, but they are going to try and sell their electric, and they've clearly the boss at Rolls has said hydrogen not for 15 to 20 years or something like that. How do you as an airline kind of weight what the industry is telling you? How do you have a sense of what is real and what is possible as an airline? Because you in the end will have to put big dollars on the table to make this transition. How confident you are that the industry is being realistic about what they can do with hydrogen?
So I mean, one thing to clarify on that is, unfortunately, one key point was missed when that statement was given, which was he was talking about large engines, large wide-body engines over the in the long term. Now, in terms of how we keep abreast of the market is really through our partnerships. So we work very closely with Airbus and with Rolls-Royce, with Cranfield Aerospace, GKN. We have regular conversations with many others. And what we're doing there is, I mean, we're trying to work together to de-risk and accelerate this whole transition, because ultimately, at the end of the day, what we are looking for is not Concorde. We're looking for a bus with wings that can fly 6 sectors a day, day in, day out for 20 years. And what we are doing here is we are providing our expertise and the operational and commercial nous, and at the same time also gaining the knowledge and the understanding of these systems, the products, the propulsion systems that are completely alien to us at this point, so that over time we are building that capability and helping our colleagues in the OEMs and so on to build their capability as well, to try and get to where we need to as soon as possible. Because echoing what James said, we see this as a necessity for the industry. Just one point I'd like to clarify as well, just in case it was ambiguous when I talked about a subfleet. What I meant there was a hydrogen narrow-body subfleet. So not that there's any intention of moving away from the tried and tested business model.
Right. You just have a range limit, a fleet with a range limit or something that that part of the fleet would have. It wouldn't be able to go from Norway to Malaga on a weekend or something like that.
At the start, yeah. But again, there's a long transition from aircraft number 1 to aircraft number 400 entering the fleet.
Yeah. So Matt, Lahiru talked about de-risking the transition there. We've got a question online here about what the airport could you begin working with hydrogen ahead of the aircraft? Start using hydrogen in vehicles or in power generation or in power storage, electric storage. There are various ways of using hydrogen that you could begin to get experience, begin to put the initial pieces of infrastructure in place.
Yeah, very much so. It's a good question. And actually, we're already doing some of that and planning to do more. So a little known fact, but there's been a hydrogen refueling station actually run by, I think, Air Products rather than us on the perimeter road at Heathrow for many years now for vehicles. There's not many hydrogen vehicles, but some, I think, emergency services, some buses have used it. So it's there in a very small scale. We have built into it, so we're a regulated business. We work in 5-year business planning cycles governed by the Civil Aviation Authority. In our current 5-year plan, we've built in capital investment, which we hope will be match funded by a government grant. We have a grant application we have in, but even if it's not, we'll carry on and do something anyway. We have a bid in to test a stand and to look at the kind of infrastructure, refueling requirements, safety procedures, separation distances, and so on, so we can begin to build our understanding. The point on vehicles is a really interesting one. The big shift that we're seeing at the moment is very much to electric. Certainly for anything small cars, small vans, even slightly bigger bits of ground support equipment. There's certainly hydrogen is being talked about a bit. There are some technologies where, you know, a diesel engine can be, or a diesel bit of equipment can be replaced with hydrogen. So we're beginning to look at that, and it's certainly plausible. But I don't think we yet know that some of the bigger vehicles, you know, fire engines, for example, might shift diesel to hydrogen instead. So we do need to understand that. So yeah, absolutely, we'll be doing that and looking at hydrogen vehicle refueling, and do we need that airside, which will help us. The one thing I forgot to mention, which is I always give a plug for in any conference like this, is we announced several years ago, and I think people may have forgotten, but if they have, let me just remind people, we did offer a prize of free landing for a year for the first zero-emission commercial service at Heathrow. So that prize is still out there for whichever airline first buys an aircraft and operates it on a commercial service for Heathrow for a year. That service, that flight, will have free landing fees.
James, you come out of the automotive industry. You saw the transition to electric. There was a start of a transition to hydrogen, but it kind of doesn't seem to be. I think Toyota's pretty much giving up on the Mirai, and maybe there are still looking at trucks and things like that. But does that mean that really, when it comes to fuel, the future of fuel cells, it's aviation? What do you think?
Well, I mean, there are other use cases for fuel cells outside of aviation, but aviation makes a lot of sense for hydrogen on a number of grounds. Right? Fuel cells are great because they're efficient, as we've discussed, and they'll offer other operating cost benefits when we've got them scaled up into these larger aircraft as well. But hydrogen in aviation makes a lot of sense because we've already talked about some of the limited network where you need to provide fuel. So you've got, unlike the automotive industry, where if you're going to run on hydrogen, you need to provide that hydrogen everywhere. That becomes very problematic from an infrastructure point of view. With aviation, we've got a very limited number of points where we actually need to service fuel. Then you've got the benefits of a highly professionalized industry, right? That fuel is delivered to the aircraft by trained professionals. So when it comes to handling a fuel like this safely, this is a great environment in which to do it as well, because you can standardize everything. You can monitor the equipment, maintain the equipment in a very professional manner. So again, you alleviate some of the other issues associated with trying to bring hydrogen to general public use in ground transportation. And then finally, really there is no other alternative in terms of energy density than doing this or SAFs, as we've discussed. Batteries simply won't scale, at least batteries that we have today or anything we can see in the foreseeable future. And this is the best way to effectively electrify the industry. You need a medium to carry that renewable electricity onto the aircraft, and that medium, in our view, is hydrogen, and converting that back as efficiently as possible through a fuel cell. So that's why I think it makes sense.
So, Lara, you mentioned earlier on about that you may with the third way of using, we have fuel cells, we have direct combustion. With the third way of using, if the world economy, like the European economy or the US economy, moves to a hydrogen economy, hydrogen energy based long term. And aviation will always be a user, not necessarily a driver of that, but it will be a key user of that. When you look at this from your viewpoint, yes, it's more efficient to use hydrogen directly, But if you take the entire infrastructure equation, the cost of the infrastructure, the cost of hydrogen production, the cost of the electricity for liquefaction, et cetera, would it not be better to just use hydrogen and SAF, and we wouldn't have to touch anything? We would just literally go on as we go today, and just the fuel going into the airplane would come from the hydrogen. I mean, we've got to look at this as a system level, not just as individual problem solving. What do you not see it that way?
I mean, looking at it as a system level is exactly what we do, and that's why we've come to this conclusion. So, for starters, from the environmental perspective, we see it as we've got to hit net zero by 2050 and stay at net zero at worst. Really, we need to be going towards zero carbon emissions, full stop. So there is the environmental aspect to it, because there are question marks about going forwards, how feasible it is going to be cycling carbon through the atmosphere, as opposed to being able to not emit carbon at all. And we will come under more and more scrutiny as an industry, maybe not today or tomorrow, but as the rest of the world decarbonizes. That's the first point. The other side of it that we look at is when we look at it from a system perspective. If we look at it just on the aviation ecosystem, certainly it's much easier for us to look at it in terms of, well, if we've got SAF, same plane, same pipes, same suppliers, etc., it's easy for us. But the problem is looking further and recognizing that there are significant challenges and investment that's required for hydrogen to be delivered to an aircraft in liquid form, no less. But if we look further up to the end-to-end energy ecosystem, that SAF requirement is also requiring, in the form of power to liquid, it's requiring a massive renewable energy infrastructure installation further upstream. So whereas we might be looking at this in isolation and saying, okay, it's much easier for us to not have the infrastructure at the airport, what we might be having to say is that the Outer Hebrides now has to be planted entirely with wind turbines to be able to generate that additional power.
Matt, do you have any thoughts about really what is the best way to use hydrogen from an airport perspective? Do you want to really get involved in handling hydrogen, or would you rather it just comes in the form of SAF?
I suppose at a simplistic level, yeah, brilliant. If we could use today's infrastructure, that's one of the advantages of SAF. I suppose we're pragmatic at an airport that we don't design and make engines. We're not directly actually in the fuel value chain, so we're likely to be a taker of technology rather than the fundamental deliverer of it, I guess. So we need to anticipate these different worlds. And at the moment, we work in partnership and scan the horizon and have conversations with all the significant players in this space. And our view is we're going to need to prepare for a mix of SAF and hydrogen. SAF is, we tick the box with airport infrastructure because it's unchanged, and aircraft and refueling practices. We don't tick the box of upstream manufacture, which we've got to get sorted through the right policies. Hydrogen, you also need the upstream production, but you also need to make some changes on the airport. And we need to prepare for that. We're just not quite sure exactly what time frame that will happen over. I would summarize it at. I would say the whole thing, ultimately, this balance between SAF, hydrogen, and we shouldn't forget removals as well. I think that it will continue to work almost like a kind of, I mean, this is a bit of a naff analogy maybe, but one of those old graphic equalizers for music, where as the technologies and costs continue to evolve, the exact balance between those three will shift. But will it be those three? From everything we see, we're pretty confident it will be those three tools.
So James, Phil Ansell from University of Illinois Urbana-Champaign yesterday said he's a big fan of a hybrid solution. That he wants to hybridize turbines and fuel cells. Now there are some designs that hybridize turbines and solid oxide fuel cells, but his particular design hybridizes turbines and your type of fuel cell. Have you, as ZeroAvia, do you look at that? Is there a possibility that that's how you get to scale as you start to? I know it's being looked at on the electric side. I mean, where the reserve requirement is dealt with by a SAF on the airplane, that if you don't use it, you don't use it. It just stays on the airplane and you change the battery. Are you also seeing a possibility of a hybrid hybrid approach in the future?
Yeah, it's just definitely something we're considering as maybe a first step into this market. So these studies are ongoing at present, and there's some nice advantages to doing something like that. You make maximum use of the fuel cell in cruise efficiency, but you've got the turbine for peak power events like takeoff and climb. So there are quite good reasons to do that. Fuel cell is an air breathing device, so you still need to squeeze air into it, which obviously you've got a lot of the functionality there in a turbine to do that, and you can recover energy from it as well. So these two things can work quite well together, and indeed you can use do some clever things with the water vapor as part of the turbo machinery as well to optimize efficiency. Of course, it adds complexity though, because you've got two different devices you're managing. You don't necessarily avoid some of the maintenance problems we would like to avoid in the future from shifting to fuel cells. So, but certainly something to look out for, and I think we'll see more research going on in that space too.
Matt, you have to leave us a very quick question from the audience. Have you looked at geothermal as a source of is it hot enough under Heathrow to?
Well, yes, conceivably. I mean, there's two different, from a non-expert understanding, there's ground source heat pump where you've got a large array at a relatively shallow level, and then there's very deep geothermal. Actually, we are looking at decarbonising heat, and it is on our long list of options. I was talking to Centrica last week in the UK, big energy company, who were talking about the latest geothermal technology where you do go, I think they were actually talking, if I'm not wrong, kilometers rather than just meters down to get very hot water, which is could well be of interest to us if that allows us not to have to refit all of our surface level buildings. So on the list, yes, but I wouldn't claim to be an expert, and yeah, I don't know yet. So anyway, I'm very sorry. I had this until 1:20 and I do need to leave. That was brilliant.
Thank you very much, Matt, for joining us. Thank you, James and Lahiru. It's been a great conversation. Dominic has popped up, so I'm going to hand over to Dominic. And I think actually I've bought you a couple of minutes. Thank you, gentlemen.
Thanks, Graham.
You have bought us a couple of minutes. Fantastic conversation. Thanks, Graham, as ever. Regular fixture on the Hydrogen Aviation Summit, Graham Warwick. I always enjoy his provocative questions. So really good panel session there. We ran a little bit over actually, but we will take a 5-minute break and we'll come back in 5 minutes to start the next panel. So we'll start at about 28 minutes past the hour. So if everyone can be ready, look forward to chatting through our next panel, which is going to focus on the burning question that's come across in so many panels. How do we make this infrastructure work? So not a zero-emission narrow-body aircraft, but the chicken or egg, which I think actually another panelist used earlier, hydrogen fuel production and distribution for aviation. So we'll take a few minutes quick break. We'll be back before past. Just to kick off again and finalise, and then we'll head into our closing keynote for the summit on day 2. Thank you.